Chapter 8, Text as Data. How can we use the power of natural language processing, NLP, in all of our business use cases? Using text for business decisions. Yeah. How can we do that? So there are a lot of things that I'm going to cover in this topic chapter summary, and we're going to look through a practical example of how to build a spam detection system. Email is text. What if we could build a spam detection system? We'll break down the process of natural language processing and how we can effectively use text as data into tokenization, stemming, stop words removal, word embeddings, and apply it to email as text, right? Spam detection using logistic regression. And we will cover a new algorithm, algorithm 22, PCA, principal component analysis for big and sparse data, right? And finally, we will end with multinomial inverse regression and collaborative filtering and content filtering. A lot of topics, right? So this is going to be super interesting. So let's dive into it. So first of all, why do we need to use text as data to solve business problems? Anytime you have a customer who's writing things, inputting a form, or reading things that you want them to read on a digital website or an app, they are interacting with your text data. So businesses today have digital presences, digital transformation. Everyone is getting online. And so that means that there is a lot of insights and data now in text form that either your customer is reading or is writing to you. And we would want to start getting insights from that data, right? So here are some examples, and I'd like you to start thinking how some examples comes to your mind for your businesses as I go through some of these examples. First, let's say we want to apply this in the finance industry, right? You are in the business of, let's say, analyzing and evaluating companies, and valuations is one big part. And so what you do is you look through company filings, the quarterly reports, the annual reports, the 10K, 10Qs, and you want to find out insights. What is the CEO talking about? What is the CFO talking about? And one way for you is to read it. The other way is for you to write a machine learning algorithm that tells you what are the key things or key insights from this document. I'm not talking about summarization like ChatGPT does, but also what if you could find out themes, which also ChatGPT does, by the way. But what if you could find out themes? When is there a theme of using more AI for this company in their financial report? That's one example. You want to assess tone. Is the CEO bullish, bearish, and can your machine read more insights out of your investments? So that's one example. Finance. Social media. What if you could build a sentiment analysis, tells you for all the Twitter feed, Twitter data that's coming in. This was before the Twitter ban on reading data. What if you could find out sentiment, real-time news sentiment about how things are going? Let's say you want to find out about the war in Ukraine. What if you could find out all of that? So you could build a sentiment analysis using machine learning to read in lots of data and say, hey, the sentiment is positive, sentiment is neutral, or sentiment is negative. So there are various such mechanisms in which you can use and build this sentiment analysis to on social media feed. Similarly, for macro, what if you could predict the future? Well, you can't predict the future, but what if you could at least read and have your machine learning algorithms read through the FOMC, the Federal Open Market Committee meeting announcements, and give you the tone, whether there's going to be uncertainty in the policy for the Federal Reserve or whether they're going to be more dovish or hawkish, right? So there are so many things you can do. You can start thinking of like using this in analyzing the political speeches, finding out reviews that are coming in for your products. Like any e-commerce application, you would have customer feedback also coming in. So you could start to predict what is going to be your sales trend or customer retention or customer churn based on customer complaints, customer texts, customer emails, customer reviews. So there's so much text coming in. I just gave you some examples. You could start to think about more. And we're going to go into this specific one in more detail, email spam detection. So I gave you a lot of examples. In the comments, can you give me an example on how in your business you can start to use and process text either coming in or text going out? I didn't give you an example of text going out, but you could imagine this one, which is if you are trying to list a house on Airbnb and you will write things about your house. It's a spacious house. It has certain amenities and things. What keywords to use that has a higher predictor for you to get higher rate for your rental property? Well, a machine learning algorithm can tell you that, saying, hey, these words are good words to emphasize or use or not use. It can read other listings and find out, hey, that's working well for them for these reasons. So anything that you post or that you get from your customers is all game, meaning you can make that a better decision. So that's the key insight from this slide, which is anywhere that your customer is reading the text that you want them to read or is giving you insights in the form of complaints, reviews, follow-ups, communication with your sales reps, etc. That's where you can start to think about using AI and machine learning, specifically natural language processing, to build a better business case to get insights from your data. Okay, so in the comments after this video, write down some examples or pause this video now and write down some examples. Yeah, how can you use data insights from the text that your company is generating? Think about all the places where your company is either making the customer read the text or getting the text message or text email or text complaint or whatever that is. Yeah. So hopefully now you're super sold that yes, we do need data, that we can build data insights from text, right? And why we should use text data for business problems. With some of these examples, now it's clear. So now let's go deep into one specific example, and we can start to generalize this into many examples. So like, let's say you want to build an email spam detector. This is like the 101 hello world example of a basic application of natural language processing. This is simplified here. You could make this super complex and much more sophisticated, but just for getting the high level understanding, how would this system look like? Again, look, this is a system that reads text and classifies whether this is a spam or not a spam, right? Now that's powerful. What if we didn't have all the power that we now have with Gmail, where it's really good at detecting spam, so we don't even have to say this is spam or not spam, it automatically moves them into the spam folder, right? So this is a very powerful example of how Google used spam detection in their Gmail system to make it so that the customers get the best emails in front of them and not have to worry about unwanted spammy emails. So how would they go about building such a system, an email spam detection? So at a high level, they will gather data. They will know, what are all the emails that have come through, and they will do some sort of pre-processing. In this case, I've taken an example from this website where it was, not an English set of emails, so they translated that into English, or they would use something that understands this new language. And so then what happens is the first step is you do some sort of pre-processing. You gather the data and then you do some sort of pre-processing. The pre-processing step is where you clean it. In this case of email, you can start to think about this as breaking things down into smaller words and then removing common words and, trying to clean the data. So that's this step. First is gather the data, that's green. Clean the data, that's this darker greenish color. And then you try to get features out of that data. Again, remember, you would have to transform your data that is text into numbers, because that's when machine starts to learn, and you can extract features and say, hey, if this word starts to appear, it's most likely spammy. If it has a certain set of links, then it's spammy. So then your machine will start to learn from this data that says, hey, when I see A, B, and C, this is spam. Something like that, kind of a heuristic. Your machine will learn, it'll extract features, and then you would select features based on which has really good predictive power. You would balance these trifecta of accuracy, precision, recall, F1 score, and then you would say, hey, I'm going to test this. How is this actually working in production? And then you would deploy it and say, hey, now it's working well, I'm going to deploy it. So those are the 4 steps. You gather the data, you pre-process it, you build a machine learning model, and then you find out which model is really doing well, and then you test that model and then evaluate and put it in production. So that's the high level step. But it all starts with, as you see, gathering the data and processing this data. So now let's get into a little bit more detail of some of these steps. I'm going to go into tokenization, stop word removal, stemming, feature extraction, embedding, and some of those things that are going on here. So let's get into tokenization as the next one. So what is tokenization? Tokenization is splitting input text into meaningful parts. Remember, you just got an email that had a lot of sentences. How can the machine make sense out of it? It's gonna, like a human, the machine would also parse different words in a sentence and break it down, right? Similarly, tokenization is that step. You break down large sentences into meaningful parts. Now, what is meaningful parts? Okay, so there are many ways in which you can break down words into meaningful parts. But the key essence to remember is a word is something that you and I understand, but the machine doesn't understand. So the word has to be now converted into numbers or a numeric representation so that the machine can learn from it, right? Machines run on numbers, numeric inputs. So the text has to be then transformed into numeric inputs. That's what I mean by meaningful parts. And there are many other things you do as part of tokenization, which is you, in this process of creating this, you take this text and then you break it down into tokens, right? Like each of these words is a token, and then you associate them and you give them a number, right? So that's the most simplistic way of saying, hey, I'm going to convert text to number. Simple, right? And then you do it in a way that's like the basic. What if you could also do things like stemming, stop words removal, counting how many times certain numbers are coming in, and figuring out several words that get together, like n-grams, grouping them together. And you can then start to build insights from this data, right? So just saying this is equal to this number, this is equal to this number is just one basic part. But you now need to add more to it, more layers of complexity on this number to represent this, not just in a simple mapping, but also numbers that encode like things like stemming, stop words removal, counting, and all of that, right? So what is stemming and stop word removal? So there are a lot of words that we use in our sentences like on, the, and, with, etc. We want to just remove those common words because they don't add a lot of value in the context. And so removing these words that occur commonly across documents is that process of stop word removal. And then stemming is like you have several words that you can create from the word create, which is creative, creating, created, creating, creates, but they all mean create. So it's about stemming is that process where you process, prefixes and suffixes are removed to get the root word. So that's that stemming process. So take the email, you transfer that into numbers, but then also you apply stemming and stop word removal so that the words that you do convert have a lot of meaning, and then that has a lot of value. So that's one more layer. You not only converted them into numbers, but you also removed some of those unnecessary words that were not adding a lot of value. Now, what if you could take this tokenized, clean set of words and add one more layer of value on top, saying, hey, which of these words, are connected to each other, right? Because that's how we speak. When we add meaning to things, we not only parse out the words, but we also figure out, like, when this word is used in this context, that's what it means. So that piece of connecting what words mean and which words are similar words and semantically similar and come together, or which words are used together, that insight, that encoding is the word embedding. It's basically you are adding one more piece of information in your numbers that says, hey, what does this word actually mean in context of this other similar word that it actually goes with or is same as that word, and things like that, right? So that's word embedding. In a sense, you're building a matrix, an n-dimensional matrix that tells you for a given word what is its relationship with all the words that you care about, right? So that's like n-dimensional metrics. So in this case, you could say, hey, if a review is along this blue line and all of these words are coming, that means it's a positive review, meaning it's going in the right direction. And when some of these words are used, it's in the right positive sentiment. So you could learn that. When it goes into this red line, it's like, oh, this is like going in the negative direction. And the green line, it's like, okay, it's not good, not bad, but it's somewhere in between, right? So you could start to build this is a three-dimensional image where you can imagine words that come together or have a meaning together that you care about. You could start to build them together. So what algorithm you use for embeddings is super important. Sometimes you could build an algorithm that says, hey, I'm just going to count what words comes together. I'm going to create embedding in such a way that I encode that information in. Sometimes you could use an algorithm that says, hey, I want to know which this blue line should represent, like, let's say you were doing this for reviews classification, positive sentiment, red line, negative sentiment, and things like that. So you could start to create meaning and extract features that eventually could lead to building machine learning models that predict that, hey, this is what's happening when these words come together, this is what happens. So in a sense, embedding is adding more information for representing the words that are in your, let's say, email, and figuring out which words are similar. And then these dimensions, these n dimensions, will place this specific word in that n-dimensional matrix. And so you could imagine this is three-dimensional, but there could be n-dimensional metrics. And you can then calculate the distance between one dimension to the other dimension, and you could have as many dimensions as you want. So word embeddings is basically an n-dimensional matrix of placing words that are similar together and embedding that in a number so that the machine can understand how close this word is to this word in these two dimensions. Yeah. And so now imagine you've now built this model. That how will you build this model? You have this embeddings metrics. Once you have embeddings metrics, you can start to extract features from it. And that's where the machine learning model building starts. You embed and extract features, and then you test out which features are working, and that will give you very clearly, hey, this is the spam, this is not a spam, and that's the starting point of you to have a machine learning model. Basically, you transform text into numbers, added more, cleaned up that numbers, and added more insights as to via embeddings as to what this number means in respect to this other number for these two words. And then you can build a machine learning model that extract features that are relevant to detecting spam and optimize for various measures so that you have a really good algorithm. So that's the basis of a spam detector that we went into a little bit more depth. We went into tokenization, stemming, stop words removal, embeddings. Those are the common concepts used, but at least we get the high level of what's going on, which is we convert text to numeric representations in a way that the machine can understand and make sense out of it. In this case, the sense out of it is whether this incoming email is a spam or not. So it's a classification sense that this machine has built. You could imagine processing lots of data, like let's say the US Constitution or the Constitution in India, and build a Wordle or a word cloud, right? You don't have to read it, but you can get a lot of insights saying, hey, what are the kind of words that are used more often, which are the larger fonts, and you can get and compare and get a lot of insights. When you have lots of text, you may not have the time to read, but a Wordle can get you a lot of information. Similarly, different parties, right? You can have like which of these two words come together and assess very quickly, like, hey, what is this whole manifesto talking about? In this case, the Congress Party, and then the BJP party, and then you can get a sense of like what is it that's important to them in a very quick way. So building these Wordles is also an important application of, you know, processing text that's coming in and then finding out in summary what it is about. What is it that this text is telling me? And then once you find out some insights, you may want to go deeper and say, hey, I'm gonna focus on this scheduled piece, and how come it's never here, right? And then you can go deep and then find out more and build models that says, hey, I'm gonna see if scheduled piece that this party talks about has a prediction in terms of how this party does, in terms of who uses what speech and whether they use this word and what is their inclination into which party, things like that. Yeah. So basically you can build a Wordle, find out from the Wordle certain hypothesis. It'll get you to think, saying, hey, what does this word cloud mean? Once you understand those hypotheses, you can build hypotheses, then you can test out in data saying, hey, is those hypotheses correct or not? But without this, you'd have to take a lot of time to read through this text and even summarize what the machine just did this in 2 seconds, reading through hundreds of pages. So that's the key piece. It helps you summarize things for you in a way that you want it to summarize, and then you can build hypotheses that you can test out. So that's the application number 2, right, that we can go through. And so now what is this algorithm that I want to introduce you to, which is topic models, right? Algorithm 22 is to, let's say you have a restaurant and you have lots of reviews coming in, and you want to find out like, hey, I have reviews and ratings, and like what factors are actually contributing to lower ratings and bad reviews. Again, this requires you to now have a machine that can understand all of your reviews. Maybe you have hundreds of thousands of comments and reviews, and it's coming, you know, near real time. What if you want to get insights out of it? You'd be really lucky if you have hundreds of thousands of reviews, but you get my point. Let's say you have an Airbnb listing, similar things. You have reviews coming in, people are rating your products, or like Amazon, when you have your products being reviewed and ratings coming in, you want to find out like what's really driving these better ratings or bad ratings, and what are the factors. So that's where topic models comes in. These are the topics, or these are the factors that we can extract out of text input. And so that's where, if you remember in the previous chapters, we've gone over principal component analysis. So what we can first do is we can run the unsupervised factor modeling, like we have done, on text via the same mechanism. You first convert text into numeric representation, you create embeddings, extract features, build a model, and then what if we could build a model. But for that, we first need like, what are the topics, right? For us to build a supervised learning model, we start with an unsupervised factor model to say, hey, use this text and tell me, use this ratings, use these reviews and tell me what are the factors or what are the topics that are at the heart or that are driving these negative reviews or positive reviews. And once we get those factors from this unsupervised machine learning model, we can then say, hey, let's say this waiter has a big role to play, because let's say that's what the factor model tells you. Factor model is nothing but a NLP model that will tell you what are the factors that the natural language has embedded in it. Now, once you find out that factors, and that could be causes for positive or negative reviews or the summaries, then you can ask for labeling for certain specific comments and say, hey, why don't you label this as positive or negative by a human? Once you do those labeling for those factors, but remember, you got those factors using unsupervised factor modeling. Now that you have those labels for those factors, because now you have a specific areas that you're focused on, then you can build a supervised machine learning model on this labeled data and say, hey, is it true that there is a positive negative lift because of these factors? But you're able to greatly reduce where you go after, what kind of things you go after, because you're able to use topic models. So in a sense, right, you are converting large amount of text into matrix of numbers, and you can summarize this through numbers. You can say, in this case specifically, you're building a covariance matrix, and it uses statistics to summarize this large amount of data points, this large matrix that you have in covariance metrics. And you can say, hey, it captures the direction, it captures like the spread, and it does all of that. And once you have that mathematical numeric representation of the data that's coming in, then you have all the power of machines to learn from it, right? So topic regression extract topics or drivers or factors that drive certain outcomes based on the text using this three-step approach. Find out factors using unsupervised machine learning model, get those factors to be labeled, run a supervised machine learning model on those factors to prove the positive negative lift, and you do that at the heart of this, converting all your text into data. And so there's a really good video by Serrano Academy on YouTube, and it tells you how a lot of text that is n-dimensional text that can be translated into this numeric representation, in this case two-dimensional representation here, but you could imagine n-dimensional metrics. It tells you how variance can be calculated, mean can be calculated, and how a covariance matrix can be calculated. But in essence, it's summarizing all of these two-dimensional data points into these 4 points. So it just captured all that meaning of all of these data points into these 4 points. And so now machine can still run off of this, and it has value captured in it. So I'd highly encourage you to go through this video if you don't understand how, in this step, as I said, hey, it's gonna summarize this big sparse data with lots of text reviews that you have, or email, or whatever text source you have, into this summary table. And so it does that mathematically using a covariance matrix, and then runs algorithms on top of it. So now let's find out if we can do the reverse with this new algorithm called multinomial inverse regression. So in the previous example, we saw how we can predict from this topics, what are the lift in ratings for restaurant reviews, right? What comments are coming in, what reviews are coming in, and how it impacts the ratings. But now what if the opposite, which is what if you're given the ratings? Can we find out what topics are at the heart of this, right? What if we are given that? And so an example that the author uses was he built this sentiment analysis during a presidential election, and he found out that, hey, there's this Twitter data that came in, and he was able to build this model that told in near real time, like, what is the positive sentiment, neutral sentiment, negative sentiment for each of these presidential candidates. And so he built this using similar example that we've talked about earlier, which is like, hey, lots of data as input and build topic models to find out topics that are being discussed for each of these candidates, and then did manual labeling to find out, hey, positive, neutral, negative for those topics, for subset of those tweets. And then he was able to build a machine learning model that says, hey, given a tweet, I can tell you whether it's positive, neutral, negative for a specific presidential candidate. So that is pretty amazing. What if we could do that for any topic that you're interested in, right? So there's Twitter data that's available, threads data that's available, and you can build some sort of a sentiment tracker. So that's the final algorithm. Not yet, actually. Collaborative filtering and content-based filtering is actually the final one, which is if you've gone to Netflix or if you've gone to any recommendation system, Amazon, right, Pandora, what they do is when they come up with a recommendation, you found out, you'll be like so pleasantly surprised that, hey, I was recommended this song that I really like. I never listened to it, but it knows what to recommend to you. How is it doing? It's doing it using collaborative filtering. What they do is they find out that, hey, this person is very similar to this other person. And so if one person reads this, then we should recommend the same article or the same movie or the same song to this other person because they are similar. So when you are able to group people based on similarity, right? That's when you can start to use, because they have similar choices, that's when you can start to use collaborative filtering. And that is very powerful. If this lady has a set of movies that they like, and it's very similar to what movies this person's like, you can start to imagine that a new movie this person sees is the movie this person will also like. Using the power of collaboration, power of other people's insights to recommend things, movies, songs, articles, whatever it is, that has text or that has, because even movies can be converted into like text because there's subtitles and there's tagging and reviews for the movies and all of that, right? So collaborative filtering is that. Content-based filtering is more like based on the interest. It starts with the article itself. The focus is on the article or the focus is on the content, and it finds out similar content independent of other people. So if a content is similar to the other content, then the other content gets pushed / recommended. Here it's about like bucketing based on people. There are various nuances here as to when you use collaborative filtering, when you use content-based filtering, but in a sense, these are algorithms that run on text data or run on this large amount of digital data that we are all generating and are able to give us better insights. We are all left delighted when we see a really good recommendation on Netflix and we love that movie, or on Amazon Prime, or like a song that we really discovered because someone else helped recommend, via their collaboration filtering. So that's when new things get popped up here. Similar things get popped up here. So there's different nuances here on when you use what algorithm. So we went through a lot. This is the first slide that existed before as we started this. But in essence, folks, anywhere where you have text, there is a business case to be made to see if you're using that text correctly, or if you're not using that text correctly for better business insights. Are you mining information from your text? If you're not, think again. There's got to be a place where your customers are interacting with your businesses by either sending you things that are textual, email, text, SMS, customer relationship management, complaints, bugs, tickets, so many things. Or if you're providing information outside, you need to use data to back you. So as I asked you at the very beginning, now is the time. Can you think of an example where your company sends textual information to your customers to read, or gets that information from your customers, and how can you use that to get insights? Add that in the comment below, and I will see you all in the next chapter. Thanks.